So this is going to be part 2 of writing polynomials. Since we weren't able to finish in the class, I'm going to attempt to do it all on my own. Please use the YouTube comments to ask questions and things like that, or if not, you can always set up an appointment with me. So now we're going to talk about writing polynomials in equivalent forms. So basically what we're doing is if someone gives us a polynomial, let me turn my pen on real quick. Sorry about that, guys. Should have had that on already. All right. So remember, polynomials have x's and exponents essentially. So something like this would be a polynomial. So that's what it means by polynomial. It means many numbers. And remember, this is the case where x squared, this is a number squared, so it's its own number. We're going to add it to another number. And we're talking about equivalent things. So the box method does come up a lot. If you guys are having trouble understanding the box method, make sure to make appointments with me. All right, so we're going to talk about factoring polynomials. And normally, the way you want to think about factoring a polynomial, oh, this thing keeps like glitching on me, is this idea of a perfect square. So sometimes there's what's called a perfect square. This is honestly a really hard thing to memorize. So if you guys don't have this memorized by the end of the class, it's fine. If anything, just write this down as a test or just as a reminder. So if this is x squared, what this is saying is our a is this x and our b is whatever this squared. So if we take the square root of 25, 5 times 5, these two are couples. So the way I usually remind students about this is if it's a couple, since this is an invisible 2, if it's a couple, it gets to go outside. So this is a 5. So we're going to submit that as x and 5. And they'll show it right here. They're taking the square root. This middle term is this 2 times x times 5. 2 times 5 is 10, so that's how they get that 10x. That's a perfect square. So when we're doing this, since this is a perfect square, the way we would write it, you can see it a little bit better down here, is this idea of x plus 5 squared. That's what's happening right here. Is they're breaking it down, they identified what an A is, what their B is, and they do it. Another property they're probably going to talk about is called dose. The reason why I call this dose is this is what's called difference of squares. Difference of squares is this idea that we have a square and another square and we're subtracting it. So since this can be square rooted, we can take the square root of this. The square root of 9 is 3. So we take the 3 out. And if we're dealing with polynomials, what we're doing here is we're going to cut this in half, and this is going to end up being x to the 1 power. So that's why this becomes 3x. X to the 1 is just x. And we're going to subtract whatever the square root of 9 is. So our a is this square root of 49. I believe it said 9. I meant to say 49. 7 times 7. That's the only way to get 49, besides 1 times itself. So our b is this idea of 7. So that's how they're identifying it right there. Our next one here is to use the formula of difference of squares. So the way to remember it is it's always a plus b times a minus b. That's what's known as the difference of squares. So you're going to have a plus and a minus sign. They're kind of backwards here. That's how you would factor binomials. Those are the two special cases. Is there another case? I'm not the biggest fan of this one, the sum of cubes. So basically the ones you would really need to remember is the difference of squares and that's pretty much it. Because the perfect square is something we will talk about later, but you don't need to memorize that formula. So what we're gonna do here for the, again, have this written down somewhere, guys. It's not gonna help other than just this test. So just have it written down, at least for this mastery test. So the idea here is we're doing sum of cubes. And I was feeling if we're doing sum of cubes, we're going to do difference of cubes. And that's this formula. You'll see that the next formula is this idea of um, the difference of cubes, which is literally you're just going to change these two signs. So if it starts with a positive, the first sign is a positive. The next one you'll see is this idea over here, the difference. See how if we start with a negative, it starts with a negative, but then it becomes positive. This one, even if you look at this top one over here, this one is still positive. And we're going to be doing the squares of them. So to look at this one, we're going to do the x cubed. So 2 times 4, 2 times 2. So luckily, this has a perfect cube. That's how they get this 2 here. And then x to the third, the cubic root, this is the same thing as saying x3 divided by 3, which is just x. So this is this 2x. Our next thing, 27, how can we take the cube root of 27? Well, that's 3 times 9. If you guys don't have these memorized, you can always try entering it in the calculator, seeing what's work. Cross that out. This breaks up into 3 and 3. So we have a group of 3. So this only works if it's a sum and these are cubes. I really wish we were doing this in class because there is more I can explain on this. But again, leave comments on the videos. So that's how we get this 2x and this 3x. So now they want us to break this down. So if we look at this, if we look at the formula up here, it's a plus b. Okay, so that means I'm going to do this x plus our b, and then I'm going to do this 2x squared plus, I believe there's a 2 in the middle. Nope, there's just a minus. I'm so sorry. That was my bad. This is going to end up being minus 2 times our a times our b. Now, this is really difficult, guys, so I don't blame you if you feel lost right now. This is a tough part of this, and we're going to put plus 3 squared. And then we're going to simplify the inside, so this becomes 4x squared, as we see right here. This 2 times, oh, this was my bad. There was no 2. If you look up here, there's no 2 in the front. It's just supposed to be minus 6x because we have this minus right here. And 2 times 3, that's going to give us that 6. And then plus 9 because 3 squared. So that's how they're doing all of this work. You can see it right here as well. They didn't put a parentheses here, but I really think you guys should. It's good practice. Now we're going to do difference of cubes. Same thing. If we can take the cubic of this, which is x cubed, the cubic root of x cubed, these two basically cancel out because it's 3 over 3. That's just a 1. And 64, well, you can see here it's going to be a 4, but if you wanted to kind of take a look at it, what happens here is I know that this is 8 and 8, and then I go like, oh, okay, cool. Let me take a 4, 4, 2, 2, and I'm like, wait a minute. So I can cross these out. I can be like, well, here's a couple, and if I do 2 times 2, then that's also a 4. But let's pretend I didn't know that. I would be like, okay, so I'll go with this, 2, 2, and then here I'm like 2, 2, and I'm doing a cubic, so I have this group of 2s, this other group of 2s. These get canceled out because I broke them up. So I have a 2 on the outside and another 2 on the outside of this cubic, meaning that we just have a 4 and we don't need this anymore. So that's how they get that 4. Again, if you guys are having trouble with these, let me know. That way we can study it outside of class. Um, so from here, we're going to be doing this. Now, the way they figured this out, you can see it right here. They have this our A, we said, was this X. Our B was this, what was it again? I believe it was 4. Yeah, B is 4. So they're plugging in this A into here, making this, and that's what's allowing them to do all this. So if you do x squared, that's our x squared right there, and then we're going to do plus. And keep in mind, there's a minus here. I think I glossed over that really fast. I know I mentioned it before, but if we're doing difference, we start off with this minus right here. You always want to do a minus there. All right. And the next thing is this is a plus. So it's the opposite of what we did over here, where this was a plus because it was a sum of cubes. It starts off with plus and then it goes to minus. So again, that's one way you guys can remember that. Otherwise, honestly, you guys just have to write these formulas down. That's the only way to do it. And difference of cubes. I believe that's the last special case. Polynomial. So this idea, this one you have to practice no matter what. You always have to understand greatest common factor. Now, first let's figure out what the word factor means. This means can multiply, something that can be multiplied, right? So I think I've went over this before. If we have 2 times 3 equals 6, this is the product. These are the factors. So they're things that can multiply into something else. So we're thinking about things that go into them, that can factor into them. Common means the same, common. And greatest means biggest. I don't think I really need to break that down, but it's this idea that we're looking for the biggest number that's the same that goes into all of the numbers. So if I look at this, all of these have at least 2 x's, right? Technically, the biggest number is x4, but it wouldn't be a factor. Factor means multiply into. So x2 goes into all of them. Okay. Now looking at this, I'm going to guess that 6 can go into all of them. And I'm not just guessing that because I have the answers turned on in here. I always want to try to guess the number in the front. So if I were to factor this out, I would have to guess a 6. You can also do a 2. 2 is a common factor, but it is not the greatest common factor. 3 goes into everything here too, but again, it's a common factor, not a greatest common factor. So that's one way to kind of remember doing these. This one, when you're factoring it out, the idea of factoring it out, of factoring something out, is basically division. What is 6x to the 4 divided by 6x squared? This cancels out. The 4, take away this 2, we get x squared. So that's how we get this x squared here. Then we have 24x cubed divided by 6x squared. This subtracted by that is just x. And 6 divided by 24, that's just a 4. And you can guess what probably happens after we divide by this. We're going to get this negative 12. All right. And then from here, they're saying like, oh, we can factor this. Well, how can we factor this? And this is what I don't like about them teaching you the special cases, is they never taught you how to factor when it's not a special case. So if we factor this out, we have this x squared plus 4x minus 12, which this wouldn't fit in these special cases. So this you have to do a box method. Put your x squared here, you put your 12 here, and you're going to get this 4x over here. So you always kind of want to figure out what you're doing. And this is a negative 12. So the way I would think about this, aside from looking right here, obviously, keep in mind that we already factored out the 6x squared over here with the GCF. So that's how come there's a 6x squared out here. Is I'm looking and I see that this is a positive. So that means my biggest number has to be positive. Well, if I try 4 and negative 3 to get that negative 12, it's like, wait a minute, that's not going to be big enough. So I would probably try something that has a bigger gap. So I would try something like 6 and negative 2. And the reason why this works out so well, x times x is x squared. And then if I have 6 times x, that's x. And then if I do this, I get negative 2x. Well, if I add these two together, this negative 2 and this positive 6, I get that 4. So that's what come to get this negative 2, which is right here, and they get this positive 6, which we can see right here. And the reason why we had to have a positive and a negative is because this was negative. So finding out that this was a positive number helped me figure out that the positive had to be bigger. And make sure you guys are doing the practice before you take your masters. It just makes it a lot easier. All right, so the next thing here, they're gonna try to drag the expressions on what we're gonna do here. So what they're doing here is they're essentially doing what's called factoring by grouping. This is a very tricky skill to do. What they're doing here, this one's actually not that bad because it's a trinomial, or 1, 2, 3, 4. It's a quadnomial. What they do is they break them up, the first two and the last two, and then we're going to try to take something out of here that we can also take the biggest GCF, that's redundant. You just take out the GCF. The GCF was 2x squared, so that's what they're doing here. So then we're going to divide it out. We're going to divide this by 2x squared, divide this by 2x squared, and we're going to get this. This was simple because all they did was just bring it down. Now we're going to look for the GCF here, and that GCF is negative 5. Negative 5 can go into both of them. And then what we're going to do here is we see that this and this are the same, which is right here. So all we're going to do is combine this term and this term right here. And that's how we drag these in. So self-evaluation, I would say if I were to rank myself, I would do 3. These concepts are hard to understand, and they are. Like, if you guys get them right away, more power to you. I spend a lot of time studying these, and sometimes I still kind of mix them up. I do have them memorized now, but it took years to get it perfect. So, and then of course, Adventum's going to go slow. Like 28 or something. Well, not even that far. Yeah, so we were like on 23. Adventum just hates me right now. Let's just wait for this to load. I'm going to pause the recording while this loads. Well, apparently it's a good thing I paused it because that did take a while to load. The next thing we're going to do here is we're just talking about factoring by grouping again. That's grouping these two together We know that the GCF of these two are here, so they're kind of skipping the step of grouping these together. They're just going straight to the, let's take out the GCF. So they skip the grouping step. Here, this is the GCF step. Here, they're factoring again. And that factoring is they're factoring this out. They just left it on this side. And then from there, they're like, oh, we're going to combine these two ideas and put them right here. And then from here, they're like, oh, cool, this is a DOS, a difference of squares. Because you can take the square root of x squared and you can take the square root of 9. And it's subtraction, so that's a difference. So here's an explanation of them just factoring out a GCF and then be like, oh, cool, this is a difference of squares. And then once they get to here, they're like, oh, cool, this is also a difference of squares. So that's where they get this -3 and this +3 right here. So there is a lot to factoring, guys. I'm not going to pretend that there isn't. Like, take a look at this one, for example. Again, I know I'm showing you guys the answer, but I really hope you guys are listening to what I'm saying and not just, oh, you're cool, here's the answer, let's just go. The idea here is first they want to take out this. All of these are divided by 9. And even if they weren't, you could just grab a calculator. So you could go on here. Oops. Go on here, type in calculator. Bring that closer. Add 189. Oops, what is going on here? 180. I don't understand why this isn't working. Oh, I didn't have my num lock on. 189 divided by 9, 21. I could have also seen that they're all divisible by 3, but the greatest common factor was 9. So always try to factor out this front number. Even the negative. I don't like negatives. In math, we usually don't like negatives, so always at least factor out that negative. So then from there, we get this right here. Now, this part is really difficult. It's the box method. You're always going to try to factor with the box method. Doing the other methods, they're good, but it's a lot of memorization, and you still want to do this. Just remember, this box is your first box, your last box, and your two diagonal boxes. These boxes are always going to add up to this. I'm going to erase that because I need the room for working. This is going to be x, x, and over here, I want my bigger number to be negative. So I'm going to try -7 and +3 because a positive times a negative is a negative. So that's how I'm getting this right here. So then I get -7x here and +3x here, which gives me this -4. So that's how they're getting this +3 and this -7. So factoring higher polynomials. This gets into a lot. So there's this rules that you always want to follow. You always want to see if you could factor out a GCF. If you can't, or even if you can, you have to ask yourself how many terms. If there's 2 terms, rewrite it as a power. So what they're meaning there is that if you have like 2 terms like x plus 2, you're pretty much done. Like, that's it. You already have your 2 terms. When you have it as 3 terms, you're just gonna write as a quadratic trinomial or a perfect square. It's just saying that, is there a GCF? No? Okay. It just wants you to put it in order, essentially. You just want to put them in order. If it is 4 terms, you want to group them. So that's this idea of you're going to group these two together and you're going to group these two together and you're going to factor out whatever you need to factor out from here. X, this is 1, and this one is x plus 1. So that's just how it helps us figure out. It's like a little rule, but you always want to factor out your GCF first. That should be the first thing you do, see if there is a GCF to factor. But if none of these approaches work, feel free to stuck in hopeless. It might help to reorder them. So you always want to reorder them. I don't know why you wouldn't reorder them highest degree first. That's just weird. This should be the first thing. It's not even GCF. You should always reorder them first. It just makes it easier. Better types of math. FOIL method's good. FOIL method to me is basically the box method, though. Let me show you why. These two would show up right here. Then outer, these two. So if I'm doing this, I always put my first term here on the side, second term goes here. Those two would go right here. Then I would go into this two, which would be right here, and then these over here would be right there. So this is FOIL. So the box method is just a different type of seeing how to visually see FOIL. Here what they're doing is they're breaking this up with this idea of, never been a fan of this, how to do this. Just think of it this way. It's a trinomial. This is x to the 4. How do I get x to the 4? X squared, x squared. I have a negative 27 here. I have a negative 6 here. This negative 6 tells me the biggest number has to be negative. So I'm going to try negative 9. And I'm going to try positive 3. So as you can see here, it's almost the exact same as if this wasn't a fourth. And then what they do here is this right here is going to be dose. So it's pretty much the same thing. Your powers just look a little different. So you can still use FOIL or the box method, however you want to call it, and it'll work out. So let's take a look at this one. What they're doing here is if you box method this, x6, this has a negative x3, negative 20, so it's a negative here. So my bigger number is negative. So I'm going to do negative 5 times positive 4. Let's say I didn't know that. I know these two are at least 2 numbers away, or 1 number away, because this is a negative 1. If it was a positive 1, then I would have done positive 5 and negative 4, because 5 minus 4 is 1. So that's how you end up getting these. You can kind of look at it here, what they're doing. They're treating this as an x squared, but instead of just having an x, they're doing this x cubed, and they're squaring it. And this right here is basically like pretending to be an x. So when I took Algebra 2, they called this U substitution. They pretended that this U is an x cubed. So it would be U squared minus U minus 20, and then this is easy for a box method. So that's one way of thinking about it. I know I glimpsed over that fast. I'll see if it comes up later. Here we are. So that's what they're doing here. They're substituting stuff in. So extended form of identity, they're substituting in. Instead of calling this x squared, they're just going to call it a. So they're just plugging it in and using the rules they already have. This luckily was the perfect square identity. Extended form, extended form is what I was kind of saying about u substitution, is instead of calling it a to the fourth, they're going to call it u squared plus 2u. They're making it a little more complicated because they also have another letter here. But just kind of think of rewriting it with a different power. That was actually what they were talking about in that first step. So we can rewrite this to basic powers. If it's a trinomial, try to make it squared. That way you can just box method it, basically. All right, let's get some more problems done here. So here, first thing that I'm noticing is that we're dealing with squared. So we can call it x squared, squared, how they do it, or like I said before, if you want, you can call it u substitution, u squared plus 18u plus 9, or sorry, 9, 81. I was already factoring it in my head, I'm sorry. And then here you're putting like u squared. So, okay, so u squared is u times u. And then we have 81. This is 18. So I'm going to try 9 and 9. Well, 9u plus 9u. That definitely does equal 18u. So this works out. I know I'm going fast, guys. I'm sorry. Again, you can always slow it down, rewind it to hear what I'm saying. So the idea here was that u equals x squared. So here I would write, since this is u plus 9 and u plus 9, I would call this, instead of calling it u plus 9, I would call it x squared plus 9 times x squared plus 9, which is the same thing as saying x squared plus 9. Since there's two of them, call it squared, and that's how they're getting this right here. All right, so here we go. And then you can see them highlighting. They use the highlighting feature instead of calling them U's. I like the term U's, to be honest, but they like just highlighting it. The only reason why I prefer U's, though, is because that's how it's taught. If you have like highlighters, this is a great idea. All right, so here we're going to talk about difference of squares identity. So all of this is basically just reviews of what we learned in that activity, which, to be honest, I don't like how Admentum always makes you do the activity before it teaches you the concept. I feel that that makes it harder to learn. So this is just talking about the identities that I went over. You can review this to practice it. Sometimes they're going to do it with extended concepts. So you guys can review that on your own. Here's a really, really tough one. This is this idea that they're going to try to take the square root of this, which ends up being y, or 4, because 4 times 4 is 16, and this is y. So that's how they get this a right here. This is our a. Next part is our b. We're going to take the square root of this, which apparently is 16 times 16. I didn't know that. Let me try my calculator. Clear this out. Square root of 5 to 6, 16. So I didn't know that. When we're doing the square root, that's kind of cutting this in half. So that would be x to the 6. So the square root of x 12 is the same thing as saying 12 divided by 2, so x to the 6. So that's how they're getting the 16 here. This is our b. Then from there, now that we figured that out, oh, I'm sorry, this is our b squared. That's that. So what are they doing here? Oh, oof. Honestly, guys, if this, like I said, this is a tough concept. They're basically, let me show you right here all the work that they're going into here. They're doing what I did over here, and then they're squaring them, and then they're doing it again. They see that there's a dose again, So this was a dose, and then they did dose again over here. When it comes to this, just memorize the formula or write it down. Have your notes out when you're taking this, because unfortunately this is a tough. They're trying to cram so much information, which is the reason why we couldn't finish this in class anyway. But take a deep look at this, write your work down so you can understand it. If you guys need help with these during the practice or even the mastery test for this one, let me know. We can schedule an appointment and get those done. All right, so this is the sum of cubes. So we're going to be doing the sum of cubes formula again. They're using the extended form. So let's say that this was to 6. You can still use sum of cubes. So they're really cramming in these. I feel like this should have been a completely different module, but they're trying to force it in. So let's look at what they're doing here. Obviously, we know it's going to be a cubic function. Again, guys, I'm really sorry. I don't know why Adventum decided to cram in cubes. Usually cubes are taught separately from squares, and usually normal factoring is separate too. But in here, they kind of tried to combine them, which is rough. Here, they're having us identify our B, which I don't like that they call these B's and A's. It shouldn't be called that. They honestly should have used different letters here. They should have called it X to the 6 plus Y to the 6 is the same thing as this A and B. And even here, they're using, where do we go here? So here's what we're doing. They're identifying our A squared and our B squared. And then from here, we can see that they want to factor it out. So this one wasn't as bad as other ones. It is still pretty bad though, because they're saying that A squared is this. It should honestly just be saying that A is that. I don't know why they're doing that. Because the idea here is A squared is that, so then A should be the square root of that. So square root of 7 y squared. So I'm sorry. They're just pushing this way too hard, and I don't think that this is supposed to have these square symbols here. That looks like it's a mistake by them. All right, so moving on. So summary, again, guys, for this, just write those formulas down from that activity. You're going to want those formulas written down. I don't think on the mastery test they use the extended form that much, but write these formulas down. Understand kind of what they mean using substitutes. I know it's tough understanding substituting variables with variables, but keep these formulas written down. And I'll remind you guys on class on Wednesday, on Thursday. So I'm sorry I had to rush through that one. Again, hopefully some of you guys will watch this before class. If not, I'm not having this one due until Friday, just because I know we're starting a new unit soon, and I want you guys being able to finish this. All right.